Thanks, Santiago. Hey everyone, I'm Noah Deutsch. I'm one of the design interns on this project, and I'm a master's student in design engineering at Harvard.
And I'm Malika Karana. I'm the other design intern on this project, and I am a master's student right now at Carnegie Mellon.
And I'm Jasmine. I'm the CS intern on this project. I'm a PhD student at UC Santa Cruz currently.
Today, we're excited to talk to you about MARSIPAN. MARSIPAN is the Mars Interactive Pass Allocation Navigator, and we're just going to give you a little bit of a sneak peek here, and then we're going to kind of zoom out and talk about the problem space and how we arrived at this solution. So NASA mission operations on Mars depend on this sort of daily communication flow between Earth and Mars assets. And each and every day during a mission, this complex series of operations has to occur in order to operate any surface asset on Mars. And we're going to kind of go through each of these steps. First up is a forward pass. And a forward pass sends decisional data from a Mars orbiter to a Mars asset. And this data is essential in sort of telling the rover what it needs to do on the next day. Next up is the operations window. And these are the time slots when Mars surface assets can actually do what the forward pass is telling them to do. And this is constrained by time of day on Mars. Next up is the return pass. And this is sending data back to Earth, communicating what the surface asset found and what information it needs to operate on the next day. And lastly, we have a planning window. And these are the time slots when the NASA surface operations teams on Earth figure out what instructions to send the rover during the next forward pass. And the entire cycle repeats itself. Now, one of the challenges is that due to orbital geometry, these passes are very scarce. They happen, roughly 6 times a day in these 30-minute windows, and only during those windows are we actually able to send data, to and from the asset. And to make things even more complicated, failing to complete any of these sort of tactical cycles, if it breaks down at any of these points, we have a loss in operational efficiency. And what that means is that we have a day where the rover just sits around with no idea what to do, which is obviously not what we want for these missions. And now to make things even a little bit more complicated, with the Mars sample return mission that's in the planning stage right now, we're thinking about a mission for the first time where we have multiple surface assets on Mars operating at the same time. And that's created this new challenge, which is how should we allocate our scarce data bandwidth between our orbital and surface assets to maximize operational efficiency? So the amazing engineers we've been working with have a solution to this problem, and it's called MARMLADE. And what MARMLADE does is it dictates when and how much data gets distributed to and from each asset on Mars. And it creates these pass allocations. And what these pass allocations do is assist the surface operations teams in their planning efforts for the mission. And it also helps decision makers assess the trade-offs in changing different mission parameters, which we'll talk about in a minute. But of course, with more assets, we have more problems. And even with MARMLADE doing what it does really well, in terms of finding the optimal allocation, there are always still days when tactical windows can't be completed. And these sort of, as we discovered, fall into these 3 main buckets. The first is insufficient data volume. A pass just might not have the required bandwidth to send a pass. And this is a particularly big problem with the return passes where there's a larger data requirement. It could be due to poor pass alignment. So a pass that has enough data volume happens to occur during the operations window. So, and the rover obviously can't be operating and receiving its instructions during that same window. And lastly, when we have multiple assets, it could be that there's just one pass and they have to pick one asset to give it to. So it could just be that the right pass was allocated to another asset. So the MARMLADE team actually needs to manually debug these allocations and kind of diagnose those sort of 3 causes that I just listed, and really understand why the asset missed a tactical window. And insights from this process can be really valuable in informing changes in key mission parameters. And this can include things such as how much data volume each rover requires for its return passes, which equipment do we actually put on the rover, and even when to staff planning teams on Earth. However, MARMLADE outputs this dense spreadsheet format. And this format is really limiting the tool's potential for impact in these sort of 3 key ways. First of all, it makes it very difficult to understand the patterns in the pass allocations. It makes it very tedious to diagnose causes of the missed tactical windows and do the debugging process that I just mentioned. And also just makes it challenging to build trust in the tool's capabilities and thinking that it made the right decision. So our process at addressing this challenge, as Maggie mentioned, was very iterative, starting with contextual inquiry, where we really took time to understand our stakeholders' needs, workflows, pain points, tools. And then we went into this 10-week cycle of iteration where every week we'd come up with new design and data explorations, and then we'd go through sort of user testing and refinement with our stakeholders. And all of that sort of led to today's prototype, which we're excited to show you. And of course, we explored a lot of different directions on the way, some of which are sort of more pure design, some of which were data sketches from Jasmine, and really tried to explore a lot of different directions here. And through that process of iterative testing and refinement, we were able to come up with something that we're excited about. And I'll hand it over to Malika to talk about that.
So the final tool that we arrived at visualizes these spreadsheets of pass allocations that are output from MARMLADE so that the planning team can just quickly scan and identify and then diagnose the problems and the causes of these missed tactical windows. And then they can actually take action and change the mission parameters so that they can make the most of the MSR mission and the time on Mars. So to give a quick overview of the tool, before we dive into kind of talking through a scenario. So on the left side, we have our time range selector, which is where we can actually scan and select sols or Mars days that we can view in detail on the right. And on the right, we have this detailed view of the passes for diagnosis, and on the top are the view controls. And then to look at that diagnostic view in more detail, we can see each of our Mars assets are color-coded, and they're marked black when they miss their operations window. And what we're looking for always is that those forward and return passes are bracketing the operations window, because that means we have a closed tactical loop, and that means we can operate on that day. We can also see the non-decisional passes for sending extra data from Mars, and then the unallocated passes on the bottom that weren't actually given to a particular asset that kind of give us some wiggle room in the mission. So now I'm going to take you through the tool that Jasmine built, taking on the persona of someone who has been working on MARMLADE. So I have just generated a pass allocation using all of my orbiters, and I launch MARSIPAN, where I've loaded in the allocation to start navigating and diagnosing. So looking at the ops efficiency on the left, that was the efficiency of all of my assets this mission. And I see that SFR and SRL assets have lower efficiency this allocation. So I want to dig into the sols that they're missing operations and diagnose why. And going through this whole mission day by day will take me a really long time. It's 334 days. And I know that the mission has repetitive cycles. So I'm just going to start by going through a single cycle of the mission that is representative of the whole. So to see those cycles more clearly, I'm going to switch to the orbiter view. And now in this view, I can see that there's this spiraling pattern that happens at the beginning of the mission. And that's as the orbiter is getting into position. And that's what I'm seeing in these kind of curved lines here. So I want to skip past that to get to a more typical cycle. So I'll skip to, let's say, Sol 138 and start diagnosing there. So I'm seeing here that the sample return lander, or SRL, missed operating this Sol. That's why it's marked black. I'm looking at the passes themselves now to see if the problem was more due to data volume, the pass alignment or timing, or something else was going on. And I'm seeing that there are 2 return passes in a row, which I know means the data volume SRL was trying to send back had to be split across 2 passes, usually because the first one wasn't big enough. So if I hover over the first one to see more details on the pass, I can see that I was right. So the size of this pass was 267 megabits, but SRL required 275. Just those 8 extra megabits pushed over into an extra pass that was so late that we couldn't operate. And so what I'm seeing here that's really interesting to me is that if we fit our communications into the first pass, it leaves us enough time to plan and operate on this sol. So this is really cool. Now that I know why SRL couldn't operate this day and that it was because of such a small margin, I can actually go back and change the Marmalade parameters so that it can. And this will improve every cycle of the whole mission. This way I can generate a better allocation so that the rovers can make the most of the time on Mars and operate as many sols as possible. And through visualizing this, I was able to do that in just a few minutes. Doing it in an Excel spreadsheet would have made it much harder to actually reason through all of this and communicate to anyone else. So now I'm going to hand off to Jasmine to explain how she implemented MARSIPAN and the future opportunities we see for it.
Yeah, so talking about how we did this, we're taking the output straight from Marmalade in this Excel sheet format, and each of those has 3,000 rows in it. Each of the individual passes that you saw represented as those tabs with their latency tail implied. And we're taking in assumptions like, here is how long you're going to need to actually see this data on Earth to actually get it to Mars, and whether the rover can ultimately operate. I'm going to... Is this a little there? I'm going to go back to the top. We're loading in Marmalade data from the Excel output, which contains the raw pass allocations. And we're interpreting those through our application using this data binding to locate the tactical cycles, which is that pairing of the forward and return pass or passes that enable us to operate with knowledge of what the rover sees on Mars. We have these bound out to the HTML, so running straight in the browser using D3, which lets us do all of these custom SVG chart types that are really deeply connected to the data and the models that Benji's team and their stakeholders are thinking about. So where we see this work being valuable, where we see other applications that are built from Marmalade or built from the design insights we found with Marmalade, there are 3 different scopes. The nearest one is doing even more to support Benji's team to study the allocations sensitivity to different operational threats. So what he and Jack have been doing is really trying to understand, okay, if we turn down this data volume assumption slightly, if we knock out an orbiter for a week, what are the knock-on effects? And we can really see management of these different scenarios being super useful to the sensitivity analysis, and simply having the ability to compare these at any arbitrary cycle in the pass structure, at any arbitrary sol, can give us a lot of leverage. The next scenario we see is going out to management and surface operations, thinking about the mission months in advance, figuring out which sols you can genuinely operate on, and using the schedule representation to see where you can squeeze in a little more performance, where you know you don't really need the full decisional return on this sol, so you're going to staff it to that day anyway, or seeing when you can get away with staffing everyone on Earth time because the operations window happens to line up perfectly. Finally, we see in the future, when the sample return mission is active, a version of Marsipan integrated with Meros, giving you access to real-time collaboration on this is where these are exactly the passes I am using. Something happened, we couldn't operate, we need to grab this other pass. Everyone's appraised of that change.
So just to summarize the contribution we were able to offer this summer, we can see on the left is sort of how before Benji and Jack were looking at pass allocation outputs just in a spreadsheet with hundreds of rows and just diagnosing through that. And on the right is the tool that we were able to design and build this summer, where you can see it's much easier to actually scan through the whole allocation quickly and identify problem areas, and then go in and diagnose, and then empower Benji and Jack to change those input parameters to Marmalade and ultimately arrive at a much better allocation for the mission. And we finally want to acknowledge and thank our awesome partners, Benji and Jack, and the broader MSR team for all of the time and the effort that they've put in. Obviously, we couldn't have made such an awesome tool without the insights that they've helped us find. And a big thank you to our mentors, Hillary, Santiago, Maggie, and Scott, for their guidance and support over these 10 weeks. Likewise, we couldn't have done this without their feedback and support. And thank you. We can open up to questions now.
This is Benji. I just wanted to thank you guys for a really great project, and I'm thrilled with these results. And I've been talking even during this presentation with some of the people on the MSR team, and we've been exchanging how awesome we think this all came together and how we think this is going to be really effective in enabling us to communicate these results and these allocations with our various stakeholders in the future. So thank you guys, and I'm really happy with how this turned out.
I will just say that it's really satisfying to hear that from you, Benji, just because, you know, I will just say one thing. It's really not transparent how unclear it is how these things are going to turn out when we start. Because everything looks so neat and well organized in these presentations, which is also a testament to how great you guys are at giving the presentations. But I will just say that so much of the work is in determining what needs to be done. That's a large part of what happens in the 10 weeks. And it's very different from, I think, what we sometimes think of as internship programs, where the organizers of the internship program have discrete, clear tasks. And we have tasks, but they require an enormous amount of creative thinking on the part of our interns and a lot of independent thinking. So these projects that you guys are seeing here, and the, you know, and the satisfaction that Benji you're expressing are really, you know, it's not something that we as organizers are sure is going to happen when we begin. So it's wonderful to hear that you're so pleased.
And it's also, I think, really exciting just in the context of something as ambitious and technically complex as sample return, to just know that we were just scratching the surface in terms of the technical complexity, but also that this kind of initial partnership really feels like it fed lots of inspiration for ways that we could continue to build on what we've learned. And the kinds of, I think, projects that Jasmine was pointing to are ways that, you know, just kind of kick off a conversation about ways that we'd be able to partner. And that's, I think, just to kind of share one of the other things that has been so exciting about the program, with much of these projects, they really are kind of the jump start as a way to start a multi-year partnership, where we really find that there's lots that we can continually dig into. And I think one of the things that's so much fun at the when we actually go through the proposal selection process, is looking for projects that we think have the technical depth that can really, that can drive just inquiry for a very long time, and especially ones that can support, objectives as ambitious as, driving around Mars, picking up a whole bunch of samples, bringing them back, sending them back to Earth, and doing it all with more robots in the same area than we've ever had before. So anyway, just it's a very exciting project to have been able to just touch a tiny bit. So we're excited about it.
So we still have a couple of minutes for questions, but yes, the work that our interns did this summer was awesome. I especially love the fact that they were able to keep the whole food theme going through. The software for the simulation is called MARMLADE. Their package is called MARSIPAN. And in fact, the little visualizations they did for the forward and return were actually called macaroons. Although eventually they became jellyfish macaroons, but that was really cool. That was particularly creative. Okay. Thank you for all the compliments on the chat, but there is no question. So maybe we'll move on to the next project.